Hi and welcome to Cherry Pie Math. This video is going to go over two-step inequalities, which, there is a difference between one-step inequalities and two-step inequalities. The biggest difference is that this one has two steps instead of one step. So let's do some examples. Some of them are going to use the distributive property and some of them aren't. So we'll start with this one, the first one here. 5x plus 3 is more than 43. I'm going to subtract 3 from both sides because remember when we have two-step equations we use SADMEP. So we start with subtraction and addition and then we move on to division, multiplication, and then exponents and parentheses. So first I want to get rid of anything that's being added or subtracted. That gets rid of that. So I have 5x is more than 40. And the sign stays the same here because I didn't multiply or divide by any negatives. And then I'm going to divide by 5 to get rid of that 5 in front of the x, and that gets rid of that. So now I have x is more than 8, and that would be my inequality. And if I was to draw that on a number line, I would put an 8 here. It really doesn't matter. It would be an open circle because it's not included, and because it says x is more than 8, I'm going to be highlighting the part that's on the right of 8, like this. So that would be my answer, just like that. If I can make a square, there we go. Okay, and then again, if I do it over here, I'm going to subtract 11 from both sides. So I have negative 8x is less than or equal to negative 16, divide by negative 8. Now I have to be careful here because I'm dividing by a negative number. Whenever you divide by any negative number, you always flip the sign. So now, yes, this side is going to be x, but instead of less than or equal to, it's going to be more than or equal to. And then on the other side, it would just stay the same. So I would have positive 2 in this case because negative 16 divided by negative 8 would be positive 2. And so if I was to draw it on my thing, x is more than or equal to 2. So it'd be a closed circle on 2, and then I would highlight like that. So just be careful when you are multiplying or dividing by a negative, you do switch the sign. If you add or subtract a negative, it does not change the sign. Kind of like how we did here. Yes, I subtracted 3, but the sign stayed the same because I wasn't multiplying or dividing by a negative. But when you multiply or divide by a negative, you do change the sign. In this next one, I have a 3 in front of it. So I need to use a distributive property. To do the distributive property, as you might recall, you just multiply the thing on the outside by each term on the inside of the parentheses. So 3 times x would be 3x, 3 times 4 would be 12, and it's positive 12 because this is positive 3 times positive 4, and then from there I really just follow the same steps that I was before. So I would subtract 12 from both sides, so it becomes 3x is more than or equal to negative 18, and then I can divide by 3. And since it's not negative, my sign doesn't change and it stays x is more than or equal to 6. And so I guess I had a lot of more than or equal to's here. So I have this and I have 6, and then again it's more than, so I would highlight the part that's more than if I was going to draw it on my number line. All right, last one. I'm going to do this one a little bit differently. So in this last one, I use the distributive property by multiplying it in. I can also have the option to divide it out first thing if I wanted to. You don't have to. It's not going to be a deal breaker, but some people like to get rid of it. You do have to get rid of it. You have to get rid of the parentheses. You have to get rid of the distributive property first, though. Whether that's multiplying it in or dividing it out like this. So I see there's a negative 10 on the outside, so if I divide both sides by negative 10, then that gets rid of that, so I'm left with 5x minus 2. The other side will become negative 5, but we divided by a negative, and so I have to switch the sign, switch the direction. And then I solve it like normal, so I'd add 2 to both sides. So I have 5x is more than negative 3, and then I would divide by 5, and then I do x is more than negative 3/5, and if I was to draw it, I'd have negative 3/5, open circle, and then I'd highlight that side. Ta-da! So it really is the same as doing one-step equations if you watched my other video on that. But the biggest thing is you want to get x by itself. You really just treat that sign like an equal sign for most of it. You just have to be careful about the negatives. So let's go over some of those rules. So with the negative rules, when you multiply, I'll make that bullet point. When you multiply or divide by a negative, you switch the direction. Of the inequality. But if you add or subtract, it doesn't affect it. So that's the really big thing about the negatives. The distributive property needs to be dealt with first, especially with two-step equations. Needs to be dealt with first. And you can do it in two ways. You can multiply it in, which is why it's called distributive property, because you're distributing it to each term, or you can divide it out right away. But you can't just leave it there. You can't deal with the parentheses first. You have to get rid of the parentheses, and then you can do the two-step equation after that. When you're multiplying by a negative, so remember a positive times a negative equals a negative, and it's the same thing if you switch it. If you do a negative times a positive, it still becomes a negative. But if you do a negative times a negative, it equals to a positive. So for example, if I had like a distributed property like -3 and I had x minus 4, for example, and I was trying to distribute it in, it would become -3x because it would be -3 times positive x, which becomes -3x. But then it would be plus 12 because it's a -3 and a -4. I've seen students mess up on this a ton. Be really careful. If there's a negative in front of that other term, it's technically just -4. So it'd be -3 times -4, which is positive 12 in your final answer. So be careful about that. Open closed circle. Remember, it's open if not included. So like if you have this or that, but it's closed if included, which means that it is less than or equal to. So for example, like if I went back here, like in this one, x has to be more than 8. So it could be 9, it could be 10, it could be 8.5, whatever, but it cannot be 8. But in this one, it could be 2. So if I was to make a list of possibilities, I could say like 5 is greater than 2, so is 6, but 2 is also available as an option to fulfill this because it's equal to 2 as well. So it includes that stuff, kind of like when you say children 2 and under get to play for free or get to eat for free. It's including that too. So it could be 2 years old or anything under 2 as well. So here's the things to remember, kind of what we've already said on those other slides, just put on the same slide. It really is just solving like normal. The only difference is you just have to pay attention to whatever's in the middle. And remember that negatives do switch the signs, so just make sure you follow along. And if you're not sure, plug in the value for x and make sure